Hi everyone, welcome back to Coding and Analysis. And in this video, I'm going to evaluate the R squared and the mean absolute error scores for the random forest regressor model that we ran in the previous video. So I'll just do a quick walkthrough of that. So we created our function train and predict, and then we're preparing our target variable, which is the 2025 PPR for lowercase y, and the x is the features columns that the model is going to learn upon. And then we're training the model. We're using the estimators as 100 and max depth as 10, random forest for reproducibility is 42. And then we're doing a rf.fit method. So we train the random forest model using the known historical stats and traits, which is the x underscore train, to predict the 2025 target variable, which is the y underscore train. And then we evaluate the model that that we fit the training data on to evaluate the model, and we're using rf.predict x underscore train, rf.predict x underscore test. So you can see here the feature columns are going to be, for the training, it's going to be x underscore train, which will be y pred train, and for the feature columns for the testing will be y pred test. So y pred train is the historical data, the health data, all this, the stats, the traits will be this, and the y train is the target variable, and it's the same for the testing data as well. So we're going to print out the mean absolute error, then we're going to print out the feature importances, and then we're going to store the predictions for the correct subsets of the data, for the training data and for the testing data. And then we concatenate this data into one data frame, and then we create a new index right here. So we're saying, ignore the original sequential numbers for the index and create a new sequential index, since we're, if we didn't create a new one, we might have duplicates, we might have errors show up. So we just want to tell it, combine these into one data frame, and let's just have a new index from 0 to however to the last number that we have. And then we ran it. So this was our function name, and then we're saying we want the running backs first, wide receivers, tight end second, quarterbacks third, and we concatenate all these predictions right here. So now our data frame will be called all underscore predictions, and then we can see here we're outputting the results to this output file, and then this is what we're going to see in this file right here. So we're just saying, these are the columns that we want the CSV file to show. So we want the player, data split, training test, fantasy position, predicted fantasy points that our model has compiled based on all the historical stats and the health data and the starting or backup column that we have. And this is the CBS number that I compiled from I got from their website. So we want to see the differences between these two. So the running backs, it wasn't too much of a difference, the training and the testing. wide receiver, tight end wasn't too much differences in the points as well. And the quarterback for the training, it wasn't too off the testing. It was off kind of sort of by a lot, 71 points. So we'll can look at the quarterback testing and see what's going on with that 71 points. See what's going on with that. So the R square score that we're getting is where it measures how well the model's predictions match the real values. So the real values is this predicted 2025 PPR fantasy football points. So 1 is a perfect score and 0 means the model performs no better than just predicting the mean. And then the mean absolute error is the average difference between the actual and predicted health grades, which in this case, this was from the previous playlist of videos, it would be the actual predicted fantasy football points. So lower is better. Like we see here, we don't really want 71, we want 35, we want 29. So we start off with the empty Python list and call it position metrics. And then we're doing a for loop, and then we're creating a subset from this all predictions concatenation that we got up here. So that was the concatenation. And then we're saying that we want it filtered on fantasy positions, just like we did with the let's see, here we go. So we want the R square we want to see the difference between the positions. So running back, wide receiver, tight end, and quarterback. So that's why we're doing that. And then where we can get the R square score subset, the mean absolute error. So we got that, imported it from this metrics package from scikit-learn. And then we're saying right here, we want the CBS fantasy predictions that we got, and then we want our model's predictions. We want to see the differences. So we're appending this list, and then adding the position, and then the R square scored and the MAE score, and then we're rounding it by 3 for the R square and rounding it by 2 for the MAE. So after this loop, and then we're appending it, this position metrics list becomes a list of dictionaries, which is then converted to a pandas data frame for easy viewing right here. So we're creating our data frame. So we're saying pd dot data frame method position underscore metrics. Then we're printing out the results. So for this one, it's going to be combined for the training and the testing and data. So it's going to be it's going to show a lot, be favored toward the training, since that 80% was the training and only 20% was the testing. So we can see here with the training data included that we got that we separated up here that I was trying to talk about earlier. The fantasy position, the RB, wide receiver, tight end, quarterback that we're filtering off of. So it's all pretty good scores. So it's all close to 1. So that's good. And then the MAE, mean absolute error, it's not too off the points as well. 15, 27 for the quarterbacks. But then what if we want to see the testing data only? So the testing data only, we would go in and create the empty Python list again. And then we would say test underscore only. And then we will filter on the test data split. And then instead of putting all predictions right here like we did earlier, we're going to put the test only results. And then we're going to do a for loop and then create this subset and then filter on the fantasy position like we did earlier. Find the R square score and the mean absolute error score, and then we're appending it. So we're creating our list of dictionaries from this empty Python list, and then we're creating a data frame just like we did before, doing a pd.dataframe method with position underscore metrics, and we're printing out the results. So this is for the testing data only. So our best result was running back, which was 0.580, and the MAE was only 29 points off. So that was our best one out of the positions. The wide receiver tight end, that was much lower than the combined training and testing, and so was the quarterback. So you can see here, I mean, the 35 points isn't really too bad, too off. So I wouldn't freak out because it has a R square of 0.225. But for the quarterbacks, the 71.64 is kind of concerning. So let's go look at the results of this and see what's going on with the testing data. So we can see here, like we asked to show in the CSV file, we want the player data split, fantasy position, predicted fantasy points in 2025 PPR. So that's what we're getting. And then it's created a new index. It's not the index from the original data frame, but it's our new concatenated for the training and the tests. And we're creating a new index from, so we're at 1 to 281. So 281 is the total. So players in this spreadsheet. So Ty Johnson. So this is the training. So these aren't going to be, these are going to be all pretty close. Just like the R square, the MAE scores had indicated. So you can see here, nothing really too off. You have Kenneth Walker at 212. Our predictions and CBS predictions has him as 235. Bucky Irving 228, and CBS has him as 250. So let's look at the testing data, see if there's anything too off. So you can see here, Christian McCaffrey, his is way off, as our model has 124.64, and CBS model had 292.6. But then all the other ones really weren't too far off, were pretty close to what the CBS model was predicting. So that's good. So the only one that was really far off was Christian McCaffrey. And for that reason, since if we go back and look at the feature importances for the running backs, so let me go. So it's all going to be 2024 stats and a projected role. So you can see here, rush attempts, rush touchdowns, rush yards, receiving touchdowns. And what happened here was Christian McCaffrey, he was hurt much of that last season. So that's why the model it's calculating all the historical 2024 data and not, it's kind of disregarding the 2023 data. It's just saying, look at the 2024 data and the projected role, and we're going to come up with a much lower score compared to the CBS model. So, yeah, I would say the CBS model is probably more accurate, maybe closer to 250 if he remains healthy. But that's why we're getting 124. Model is putting a lot of weight on the 2024 stats, which he didn't play much. He only played like 5 games, I think, in last year. So that explains that one. And then you can see here the wide receivers, tight ends. Nothing too far off, nothing too crazy. And the training data, which is good. So for the wide receivers, tight ends, the 2025 rookies, so we didn't put any, we just put their stats, 2024 stats is 0. So like he was drafted in 2025, and really that's pretty cool. The training, he's in the training section, and our model has 158 and CBS model has 159.1. So that's pretty spot on. Um, Colston Loveland, he's a rookie tight end. Our training model has 132 and CBS has 119. So really, even though we're putting zeros for for these wide receivers and tight ends, it's still producing a reasonable for PPR fantasy football predictions. It's if we want to go back and look at the wide receivers, some of the rookie ones that we put the average of the 2024 running backs for their stats. So let's see. Let me look at one. Try to find one. RJ Harvey, so 171, 182. So that's pretty close. Woody Marks, 95, 95. That's really close. I wonder if there was one in the testing. They're rookie in the testing data. There's Jaden Blue. Okay, so Jaden Blue. So I think since he was drafted in the later rounds, I didn't put, I probably put like 90 points or 100 points, fantasy football points for him. And so the model they took those stats and put 95. So that's pretty accurate. And the CBS model has 123, so it's not too far off either. So let's look at the quarterbacks that's going on there. There's not too much difference between these for the training, which is good. So if we go in the testing data, so there's only 1, 2, 3, 4, 5, 6, 7, 8. There's only 8 in the testing data. So you can see here Aaron Rodgers, that's pretty close, very similar to the with our model and the CBS model. And Cam Ward, that's not too bad. Probably our model is probably closer 221 for points that he's going to have in this upcoming season. And Patrick Mahomes, that's really close. That's a good score, 325. And CBS model has a 318. So I guess the biggest issues are with Anthony Richardson and Joe Burrow and Justin Fields. So when I look at Anthony Richardson, I put him as like I guess like a backup because Daniel Jones, he's probably going to start some games, and Anthony Richardson's probably going to be more of a hybrid type that comes in, doesn't really start. So the quarterback's future importance was using the projected role is 46%. So that's why Anthony Richardson, this why that discrepancy, because the CBS model has him as a starter, and our model is considering him more of a backup, more of a hybrid role. So that's why that's off a lot. Drake May, that's pretty close. Drew Lock, that's close for a backup. And we can see here Joe Burrow and Justin Fields. And when I look at the CBS model, that seems kind of high. Both of those numbers, 439 for Joe Burrow and Justin Fields. I mean, probably more, maybe around 350 to be more accurate, especially for Joe Burrow. So our model had 297, so that's probably more realistic than 439, especially, I would probably say probably get into a 350 fantasy football PPR points for this season. So the 297 could be a more accurate number than this, especially if he misses a few games. And Justin Fields, he was this 203. It's calculating the 2024 stats. So he was a backup for much of those games, and they brought in Russell Wilson when he played for the Steelers. So that's why our model is only computing 203 points, because it's still factoring in the 2024 results and the stats. So that's probably on the lower range, but I don't see the CBS model as happening at 356. So maybe, if you had a good season, maybe you had it 275 or 300, maybe. So so that's why. So that's why these we're getting this testing data is getting a large difference for the mean absolute error of 71 points, because there's the 2024 data, especially for Anthony Richardson, Justin Fields, and then our the CBS model is very overinflated. It seems, especially for Anthony Richardson, Joe Burrow, and Justin Fields. So that's another reason why the numbers are off, just due to CBS's inflated fantasy football points for these players. So just because it's 71, I wouldn't argue that due to the CBS's inflated uh, projections, and due to the 2024 stats having the most weight for the quarterbacks. And then for the wide receivers and tight ends, and 35 points difference, that's really not too bad. Especially, the running backs was 29. So if I go back to the wide receivers, so really, the testing data, I don't see anything to Keenan Allen. I guess that's due to Keenan Allen. I guess ours is pretty over, since he's not even on a team, and our model was taken in, I guess, his 2024 stats and 2023 stats, I guess, and CBS's model is factoring, he's not on a team yet, and so I would probably say that number is more accurate for Keenan Allen, and then Marvin Harrison, that's not too far off. 229 Jacoby Myers. So Cole Kmet. So those aren't really too far off. Maybe Rashid Shaheed, which the 128 is factoring his injuries and stats for 2024. Luther Burden, so he didn't have any stats for listed, but the model still put out 132, which was close to the 2025 CBS model at 137. So it's really just interesting to look at all this data and kind of just compute, kind of plan out and plot out what you kind of want to do with your fantasy football draft that's coming. coming up. So in the next video, I'm gonna show the seaborn and the plots for this data. So I'll do that in the next video. Thanks for watching, and see you on the next video. Bye.